Welcome to Litwood Way. We're going to look at perimeter. And we say perimeter is the distance on the outside of a shape. So let's take shape 1 for example. Here we have a shape, let's make this 2 meters. So this is our shape A, B, C and D. So perimeter just means that we are moving on the outside of the shape. Therefore we are going to assume these following positions or the following route. We are going to move from A to B, to C, to D and back to A. And then we are going to calculate the distance that we have moved around the shape. So how do we do this? So we're going to say perimeter, we're going to use the abbreviation P for perimeter. So all we do is you say P is from A to B. These lines, we all know that this means that every side is going to be equal to 2. So this from A to B is going to be 2 meters. Plus from B to C another 2 meters. From C to D again 2 meters. And from D to A, which is our original starting position, is another 2 meters. Therefore we can say that the perimeter is going to be equal to 8 meters. But what happens when we have a shape that's not so simple? What if we have a more complex shape? So here we have a rectangle, and on top of the rectangle we have a triangle. Again we have these lines which indicates that the side on this side is going to be 5 meters as well. So we have to calculate the perimeter of this side. We are going to go, let's write over here. Perimeter is equal to all of the sides. So what you want to do is you want to get a starting point. So let's assume that this is our starting point, A, B. Remember we are moving on the outside and not on the inside. So from A we're going to go to B, C, D, E and then back to A. So from A to B is going to be 5 meters. From B to C is another 6 meters. From C to D is 7 meters. And D to E is going to be 6 meters. And from E to A, which is our original starting point, is going to be 5 meters. And this will give me a distance of 11 is 22 plus 7, which is 29 meters. And that is the distance that we have moved. Now you will have noticed that we did not take this into account. And the reason for that is because it lies on the inside of the shape and not on the outside.